So what we have here in this particular video, we have a diagram of Earth, and as you can see, there's an earthquake at F. And F represents the focus of the earthquake, and if you go directly above it, you get the epicenter, which is represented by E. Now what we have is a station at location X, a station at location Y, and a station at location Z. So what we're going to consider in this video is what waves you would get at each of the stations and what the seismograms would look like for each station. So if we look at station X, X is the closest station to the earthquake. So I suspect that you will get a P wave and an S wave because they can go through the body of the earth. And I suspect that we may get surface waves. Now, it really depends on the size of the earthquake, because naturally the bigger the size of the earthquake, the more energy that the waves have. So the more energy that a wave got, the further that it can push without dying out. So I suspect that you will probably get P and S. So I have two scenarios here. We have the P right here and we have the S right here. Notice that the difference of time between the P and the S is really small because this station is close to the earthquake. Also notice that we do have surface waves here because I'm assuming that the energy of the surface waves was great enough to make it that small distance. In the event that it was a small earthquake and we didn't get surface waves, we'd get our P, we'd get our S with a short interval in between, and we would not get any surface waves at all. For station Y, which is a little further away, I suspect that we would also get P and S waves and potentially surface again. So in this particular example, I have surface waves here in case they're big enough to make it, and I have no surface waves here, meaning that they weren't big enough to make it. I have my P wave and my S wave and my P wave and my S wave, and notice that the interval of time between the P and the S right here is greater than the interval of time between the P and the S wave right there because the station is further away from the earthquake. Now down here, we're going to address a possible public exam type question because the waves that you would get here is definitely P. So as you can see in this seismogram, we have just a P wave. In this particular diagram, we have just a P wave. What's missing at station Z are the S waves. S waves cannot shear through a liquid. And that is how we know that on the inside of the Earth, we have a core. The inner core is a solid. The one we're talking about is this outer core. Seismologists believe that the outer core of the Earth is a liquid, and we know that because the S waves, when they start moving, they die dead in their tracks as soon as they hit that outer core. So there's no S waves here or here. Then the question comes down to, do we get surface waves or not? If it's a massive size earthquake, then the surface waves are going to go boom, and they're going to make it the whole way around, and that's why I have them here. Most times, though, if you have an earthquake that's directly across the Earth, by the time the energy of those waves move along, they'll probably die out and never make it to the station. And that is why I left the surface waves out in this particular diagram.